जो हम फिजिकली हमारे वर्ल्ड में जो हम यूज़ करके हम चांद तक पहुंच रहे हैं वो कैलकुलस के थ्रू होता है. I did my masters from IISc Kolkata. I did Math, and later in the past 1 year I've been teaching various students in some other place. Calculus has been my favorite part in mathematics since a long time. It's the same thing. So he just says his paradox says that there's a finite distance to be gone, but there are infinite which are to be taken. Hello everyone, Jai Hind, Sat Sri Akal. Welcome to this new video series about calculus. Right? We will try to explore calculus in a very simple way, in a way schools don't teach, right? Conventional methods से हम नहीं सीख रहे हैं, मैं मज़े करके पढ़ाऊँगा. And it is not पढ़ाना, it is more about exploring mathematics. Calculus is a very important part of mathematics. इसके बिना mathematics का जो applicative part है, जो हम physically हमारे world में जो हम use करके हम चांद तक पहुँच रहे हैं, वो calculus के through हो पा रहा है. And calculus developed over hundreds of years, probably thousands of years I want to say, because ancient times में भी calculus was there, but not in the form which we study now. ठीक है? So I want to start this series by saying that mathematics is not about learning formulas. Of course, right? It's more about exploring the world in a new language. Calculus gives us the tools to explore the world. So let's start with this series without much ado. Okay, first about myself, I am P. Anirudha Chakravarti. You can read there. I'm from Andhra Pradesh, Tirupati. I've done my bachelor's from ISI Bangalore. I did B Math. I did my master's from ISI Kolkata. I did M Math. And later, in the past 1 year, I've been teaching various students in some other place for AMC 8, 10, 12, HKMO, Hong Kong IMO, and some other CMC contest which is conducted by University of Waterloo. And recently I joined Vedantu, and here I am, right in front of you guys to meet your amazing brains. Right? I'm really excited to start this journey with you, and this is probably my first solo video with you all. I'll be taking the Calculus Mastery course, so take this video as a trailer. Or probably how I teach, take it for that. So this is my Telegram ID. So just you can ping me. Maybe I'll see. Maybe I don't. I won't, like, just ping me, and I would love to interact as much as possible, right? Okay. Calculus has been my favorite part in mathematics since a long time, and it actually started when I first watched The Man Who Knew Infinity. You know, the life story of Srinivas Ramanujan. I was in my 8th or 9th grade, as it says here. I was crazed up about Srinivas Ramanujan, right? So in that movie, he sends a letter to G.H. Hardy, and it has a lot of symbols and all those things, and I was fascinated about learning them. Luckily, my father was a maths teacher, so I had a lot of books at my home. I tried reading them, I tried to understand them, and eventually I got the hang of it in a few months. And since then, not just calculus, I explored other parts of mathematics, and everything was fascinating. And I want everyone to be fascinated about calculus, because this is like the extension of our minds. Pure mathematics lies here. So let's start with that, right? Yeah, this is the movie Man Who Knew Infinity, and this is the screenshot of a scene where he uses a lot of integrals and all that. I wanted to understand this, and here I am, right? Okay. First of all, what is calculus? In calculus, we will see certain terms like functions, limits, differentiation, integration, and many other English words which will do mathematics for us. You see, these terms are very common English terms, isn't that? Limit we use in our sky's the limit, you know, extend your horizon, and so on and so forth. And that's what limits is about. That's where limit starts. So let's start with this. Why do we need that? Yeah, sure. So you may ask, why do we need all these things, right? And it starts with a paradox. Maybe not a paradox. You know, around 2000 years ago, people were philosophers. The scientific community was based on philosophy. Infinity was a philosophical concept. And there are numerous people who wanted to deal with that when they didn't even have the tools. Zeno was one of those people. Zeno of Elea. Elea is a place probably in the Greek. And he gave a statement saying that when I want to move from a place to another place, I have to first go through the midpoint, the halfway stage, right? So if I want to move from point A to point B, I will have to go through the midpoint. That's what he says, right? That's very basic stuff. And he doesn't stop there. When a person has gone from here to here, again he is faced with another midpoint, isn't it? Like, isn't that obvious? Like, from here he has to go here. When he is standing there, उसके लिए और एक मिड पॉइंट है एंड पॉइंट से पहले, वो फिर से उधर जाके उधर रुकेगा. And Zeno realized that this will keep on going. Zeno says it keeps on going, and there is probably infinite number of steps to reach a finite distance, because our end point is there in front of us, but there is infinite number of steps which we can take to go to the final step. But he didn't have the term infinity, right? So he said forever. We will keep on going forever. So that's what Zeno says. So he gives a tortoise example, right? And it's the same thing. So he just says his paradox says that there's a finite distance to be gone, but there are infinite which are to be taken. Now, how is that solved? I think we can easily solve it using mathematics. So yeah, that's what I wrote here. It just seems like the tortoise is going to take forever to reach some end, but the distance does seem measurable. Mathematically, we count it using limits. That's where limit pops up. Where does a limit pop up here? Zeno was a philosophical person. So if you see the distance is this much, and we are, let's say the distance is d, right? If the distance is d, then first we are going half of it, d by 2. And then we are doing another half of it, right? This is d by 2. This is d by 4. I'll go another d by 4. उसके बाद I'll go another half of it. Half of the d by 4, which becomes d by 8. So this is d by 8. And Zeno realized this keeps on going. But I want you to understand this. Zeno was 2000 years ago person. He did not have this notion. Probably he had numbers which looked very different. He had Roman digits probably, right? And he did not have the notion of decimals or the notion of fractions. Fractions or decimals ke bina, he was able to figure out something very algebraic in nature. Don't you think this is very algebraic? And this distance must sum up to d. That's what Zeno says. And this happens to be so because if you use GP, geometric progression, if you use, after a finite number of steps, you will get something like d by 2 into 1 minus 1 by 2 whole power n divided by 1 minus 1 by 2. This is for n steps, first n steps. I hope everyone knows this. It is taught in 8th, 9th probably. So, but limit comes when we are taking this forever. And forever meaning 1 by 2 will get smaller and smaller. Right? Ye chota hota jayega. And eventually it will round off to 0 as n grows. So we write it saying limit n tends to infinity d by 2 into 1 minus 1 by 2 whole power n by 1 minus 1 by 2 is simply d by 2 1 minus 0 by 1 minus 1 by 2, and this happens to be d itself. right? I hope that's clear. That's not much of a mathematics, that's just basic arithmetic, I would say. And thus, this is one of the places where limits happen to be very, very, very natural. So, now the next thing, eventually it developed, and there came many scientists, many people, most prominent of them being Newton and Leibniz. These two improved upon calculus like crazy, right? So Newton had many intuitive ideas. Firstly, he had the idea of a moving ball, of a falling apple, which is a famous example. Maybe not true, but yeah, he was sitting under an apple tree and something like that. So when things are moving, motion itself fascinated him. So he wanted to see that how something moves, how do we quantitate it, right? How do we quantify? So a distance we can measure with no problem. When we can measure a distance, we can measure time as well. We had clocks back then, and we wanted to see how much time does it take to certain distance. Okay, that was an average speed. So 5 kilometers in 5 minutes was an average speed. But can we find it an instantaneous way? At certain moment, can I find the speed of a moving thing? That's what fascinated, that's what rekindled the brains of that time, especially Newton. And Newton had the idea of derivative, the rate of change of distance. Speed is simply that, isn't it? Speed is the rate of change of distance. Now, Newton developed it, and it kept on developing. Newton gave us only the idea, the rough idea, which was very bizarre actually, but Leibniz is the one who gave us the mathematical way of writing it. We use the integral sign, we use the d by dx. If you have seen that was given by Leibniz. And eventually many people, actually, we cannot just say it is these two people who developed calculus. No, it's not true. Later Riemann came into play, and many people, I can't remember, so some French mathematician comes into play. These people develop the idea of calculus in a very, very mathematically founded way. And due to them only, we are able to do whatever we want now. We are safely sending people to space, right? Okay. Rate of falling down when a ball is thrown directly linked to the escape velocity. When you throw a ball, you understand escape velocity? Escape velocity is the velocity which a particle needs to escape the Earth's influence. It is directly connected to calculus. How we will actually see that? Whatever I am saying, whatever you are not able to get, तुम्हें कुछ भी समझ में नहीं आ रहा है ना? I will make sure कि इस सीरीज में हम सब कुछ कवर करेंगे. न्यूटन ने क्या किया, लिबनिट्ज ने क्या किया, किस तरह के आइडियाज आए. Newton actually gave us a relation between slope of a curve, and it is directly related to the area under another curve. So एक direct link दिया. Area, slope. You understand? Slope मतलब line का तो समझ ही रहे हो. But with differentiation, we can find the slope of a curve at any point. So there are crazy, crazy things which we will learn. And equations are so important in this. And it is amazing when you see that an equation will have a direct implication in the physical world. You see, when you have when you must have seen the movie Mangalyaan, right? Where India sent a rocket and sent a satellite through the rocket to go to the Mars planet. And if you see the movie Mangalyaan, I suggest it's a very good movie, Akshay Kumar and all that. So in the movie you see that they go to the apogee, right? Earth is here. They want to save the fuel. So the satellite is revolving like this. It is going here, 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 here. they want to catapult the satellite at the apogee. Apogee is the farthest point from the Earth. So from this point they catapult. So they, they leave the satellite like that, so that it reaches Mars very quickly. If it is left here, it won't happen. You see, so for it to reach Mars, it has to go at a tangential, and this is not a circle. Circle ka tangent banana is relatively very simple. So to draw a tangent of a shape which is probably an ellipse, but it's much more than that. It's much more than ellipse. So here definitely differentiation is used to calculate tangents, tangent spaces. Mathematics is filled with that. If you go further down the line, you'll actually see that the topology is filled with these things. Differential geometry. So there is abundant stuff which follows from this thing. Okay, what about the other thing, the biggest? So integration ना, अभी तक हमने क्या क्या कवर किया? Limits, differentiation, integration भी क्या है देख लेते हैं. Integration was mainly developed to find the area under a curve. How to find area under a curve? So let's start with circle, है ना? Circle को हम कैसे जानते हैं? Circle का circumference is 2 pi r. Why? Because pi का definition है. Pi का definition क्या है? Circumference by diameter. The ratio itself is pi. So circumference is 2 pi r. We will use that to find the area. So first of all, to find the area of a circle, we need to divide the circle into small places like this. So there is a big circle. I'm dividing it into 8 pieces and I'm putting them like this, right? The top ones here. So alternatively like that. You understand? I cut them further. You see that this is cut even more. It is becoming more and more compact. It is cut even more. It is getting more and more compact. So if you are paying good attention, you will see that this is what is happening at the end, right? So this becomes, what is this length? This should be r, the radius. And what is this length? If you notice, this should be half of the circumference, isn't it? Half of the circumference is pi r. So there we go. Area is very much pi r into r, pi r square. Now I understand that many people might think that this is not mathematical. This is very approximate कर रहे हो तुम छोटा छोटा करके. If you want it to look a bit more complicated, I can do that. So I'll speed this up. So if you want it to look complicated, there's a circle, there's a center. I take a small thing. This is theta. This is d theta. Area of this strip happens to be half r square d theta. Now I want to get the full area, so I will integrate. And where does theta vary? It varies from 0 to 2 pi. So it is directly equal to half r square into 2 pi, which gives us pi r square. If it looks complicated, you are in the right place. We will learn how do we get that, right? Maybe 2 to 3 lectures per week, and we will get to a place where this becomes a very easy thing to do. This is how I got fascinated. And eventually you will learn that we all learned the sphere ka volume. You will be able to calculate volume of sphere using calculus. You will be able to do many things. You know, area of circle itself, I can do it in a different way, right? I can take small circles small strips which are at the distance r, but this width is dr. Now it's simply like adding the circumferences of these small circles, right? So again, I can write this as integral of 2 pi r. So I'm integrating over the circumferences of the small circles into dr. Now this goes from 0 till capital R, which happens to be pi r square again. This is actually very fascinating, and I will make sure you all understand this. If you are hooked up, I am as well very hooked up into doing calculus. I love doing calculus. Let's continue in the next session. So the goal of this course is to make you love mathematics even more. It is simply to make you love mathematics even more through calculus. And we will relate everything, yeah, as I said in the beginning, right? We will relate everything with the world around us and see how equations translate into actual actions. These are not things which just happened. So, for example, the area which we found, circle ka area we use everywhere, yaar. Yeah. And it was used with ancient Egyptians as well. When they had to rationalize between two communities for the water of the river, they wanted to calculate what is the volume of the water in the river. So they used calculus at that time. Egyptians, they divided it into small segments, they added. That's what is integration, that's what is area. And it will still be used for us forever. And let us love mathematics, and results are bound to follow. So if you are worried about understanding calculus to get marks in exams, JEE, ISI, CMI, whatever, that will simply follow if you love mathematics. I want you to love mathematics and you will get. Marks are a very small thing. It is a very minute thing once you understand mathematics. तो मैं यही आशा करता हूँ तुम सब से कि तुम सब मैथमेटिक्स से प्यार करो. इसको रट्टा मारना है, फॉर्मूला सीखने हैं, वो सब नहीं. प्यार करो सब्जेक्ट के साथ. ऐसा प्यार करो कि तुम्हें रिजल्ट्स नहीं भी दिखे तो तुम्हें फर्क ना पड़े. रिजल्ट्स तभी दिखते हैं जब तुम रिजल्ट्स के बारे में सोचते नहीं हो, ध्यान नहीं देते हो. Fine. So yeah, finally a small quote from me. When astronauts go to the space and they land on the moon, they're actually standing on a pile of equations. With that, I take your leave. Good day, good night, Jai Hind, Sat Sri Akal.